SwayamPrabha. Digital India. Educated India.
Welcome to the lecture. This is on the symbols in oil hydraulics. In lecture 2, we have already discussed about this, how the hydraulic symbols are built, and against the components what is the symbols. Also in the last lecture, this earlier to this, in the tutorial section, I have also discussed that ISO symbols and the glossary, and here we will show some simplified symbols who are not strictly the ISO standards, but used in industries. Now, first of all, we will recapitulate some symbols, that as I have told, this is a poppet type check valve, but it is pilot operated, so that we can make the line through. That means, the normally oil is coming from this side and it cannot go from this side, whereas we can move this poppet to have the flow in this direction. So, which is operated actuated by a in this case it is a armature, means it is a solenoid operated. If we move this one in this directions, then oil will go from this to this. If the oil come from these sides, and if you do not move this one, then oil cannot go in the other sides. Okay. And this is a single plate valve, and it is a pneumatic valve or pneumatic actuated, not pneumatic valve, maybe pneumatic actuated to have this 4/2 position valve. Okay. And this is 4/2 position valve and spring return, and maybe solenoid, yeah, it is solenoid operated, and this is just the opposite of this one. And in this case, this is solenoid operated, no spring return, no spring positioning, whereas some detent positions are there. Similarly, if we look into the rotary actuator, which we have discussed earlier, that this is a symbol for rotary actuator. In this case, the triangle is not filled, means this is for the gas or air, that this means that this is an compressor. In this case, this compressor of 2 stage, in the first stage it is the gas or air is pumped with a certain pressure, and then it goes through the second stage, and ultimately the output is of high pressure. And to make such develop such pressure in a single stage, size of the compressor will be huge. In this case, the this is rotary pump and hydraulic pump, and this is a fixed displacement. This is a double pump by a single shaft. Both the pump is being operated, one is of low flow, one is of high flow, and this has usually to off the load when there is high flow is required, or low flow is required. Such pump are used, or even for low flow both the pumps are working, high flow, low pressure, both the pumps are working, and high pressure, relatively low flow, either of this pump is working. So, this is basically used with a proper circuit for energy savings. Now, we will go for much simpler symbols which are strictly may not be ISO standard, but used in industries. Now, first of all we shall consider the symbols for hydraulic tubes, pipes, hose, etc. Now, this is of course not the symbol for the hydraulic symbol, component symbols, rather this is the center line in a system. If we would like to maintain a center line, usually this line is used. Dashed line is pilot line. Also this is the top one is used enclosure outline. That means, if we sometimes we would say that there are a manifold. Actually, manifold means it consists of a few valves together, and sometimes the symbols is like that. All the symbols for all the components, like a pressure relief valve, direction valves, these are drawn separately and then it is put in an envelope enclosed by this line. This means that it might be an manifold. If you look into the component, this is as if a single component, but inside that there might have a directional valve, a check valve, and a pressure relief valve, pressure control valve, and so on. Now, this dashed line means this is usually pilot line. Why usually? I would say this pilot line. Now, there is a dash, but small dotted line, exhaust or drain line. So, in a drawing, suppose only these two lines are given, you may not be able to distinguish which is the exhaust and which is the pilot line, but in a drawing, if these two lines are used, careful study will show that this line is for pilot line and this line for drain line. Now, very often we have to use the line, one pipeline is crossing other while we are drawing the circuits. In physically we can say that these are separate two pipes. Now, suppose a line is like that and a line, and some lines are like that. What does it mean? Line crossing 90 degree, intersection not necessary. This means that these are usually, suppose these two lines are crossing each other, but they are not intersecting. In that case, we present like this, or we may present like this, that this line is crossing over this line like this, depending on which one is crossing over this. But as well, sometimes these are presented like this, and of course, this is a confusion. If we use this one and this one, we may think that this might be a connected lines, but if these lines are basically not connected, they are crossing each other. Even this one is also like that. If we would like to show that there is a junction point, four lines from four directions are connected, we should better use this one. This indicates they are actually connected at a point. This is a single point, you can say, where they are connected. This might be also like this. This is 3 point connection is like this. Of course, suppose if we do not provide this dot and line is like this, this means that this is connected. If we increase the line, then there will be confusion whether it is a crossing point or connecting point. But if simply without dot, if we mean this, that 3 lines are connected at a point. So, that you should understand, and sometimes looking into the components and function, we shall not confuse that this one either whether is a crossing or junction point. This is usually crossing point, not a junction point. So, these are for all junction point, you can say these few are, and then if it is a flexible hose, it is like that. Okay. Now, this is a flexible line. Now, this is usually this flexible line means it is I would say not the main hydraulic lines. This might be even electrical lines or some other lines which is flexible, but in a system, particularly in hydraulic system, if we use this flexible lines, it is presented like this. However, while we are making such a drawing, then you will find that this line is also a straight line, not like this. And while we are mentioning these components, so looking into a line, straight line, it does not mean whether it is a flexible or a solid line, I mean solid conduit pipe. Only thing we have to mention that component separately, but one can use such symbols. Now, this solid line means usually main line. Then if this arrow is given, this is a flow directions, usually a hydraulic medium. Why usually? If it is filled with hydraulic, if this triangle is filled, then this is a hydraulic, and if it is not filled, then it should be air or gas. Now, this is a connected, usually this quick connector or disconnector, it is like that called. So, that is symbolized like this. Say quick connector means usually you will find that when the machine is under operations, particularly for training purpose, we need to open a line and it is connected, and again need to connect it. Now, this hydraulic line connections we must take care, so that there should be no leakage and other things, and also in many cases we have to use the ferrule properly, pipe connections, solid pipe connections. In that case, to just dismantle that connection and to give a new connections, it may take a lot of time. So, instead of that, usually such ends are with a flexible hose and a quick connector. What is quick connector? It is like that, even if this is under pressure in operating conditions, if you connect, then these two will be connected. First of all, in the connections, that outer leakage path will be prevented, then internal connection will occur to give through passage of the oil from one side to other side. That means, a good mechanics, a good user, he can quickly connect this connector without a single drop of oil to the outside. And so this already I have discussed these three lines, and then this is a plug point. If in circuit, sometimes you will find that a line is there and then this is a cross. So, looking into this, we can say just a plug point. Usually such plug points are kept not very often, but sometimes we can have another system to be connected there, or maybe some measuring point. We can put some gauge there and we can measure the pressure, etc. Now, other symbols, which is hydraulic connector, check valve, etc. Now, if in the line such arrows are given, then this flow can be restricted, that flow can be regulated. Now, solid lines means main lines, and this is usually for the pilot lines. Okay. And this is with a fixed restriction. Okay. And this one is the flow divider. This flow is being divided into two directions. Now, what is there? You can say that any T connections can be done, but this divider is designed in such a way there will be equal resistance. Okay. So, if the pressure demand and both the line are same, then flow will be exactly divided into two parts, equal parts. So, flow divider is used for that purpose. Now, this is a throttle valve. In that case, just a restriction. In that case, this is throttle, fixed or variable adjustment. These are usually used to control the flow. Now, this is check valve with a spring return. This is a check valve without spring return, and this is again quick disconnect with check valves. This one, the quick connector and check valve, and this is a connected and this is disconnected. This means that in a circuit, if we present this one, that means that line is connected by quick connector, and if we show that these symbols, this means that normally it remains disconnected. Now, in this case, what we find that this is same as before, only thing this is only one check valve is then and other has no check valve. Then this is quick disconnect without check valves, there is no check valve. Okay. And depending on the purpose, these are used. Say for example, if we use this one in a line, then normally what we find that oil from this side cannot move this side and oil from this side cannot move the other sides. Then what is the use of such connections? Usually these valves are being operated by an external operation is there, pilot operated. That means normal condition it is a check valve, but if you send a signal through the pilots, then it will be connected. Okay. In this case, suppose we do not need such pilot operations, simply connect and to disconnect, then this will be used. Now, filter. In the filter, we have not shown that ISO glossary, but in case of this filter or even simple strainer, filter or strainer, we use this diamond like a block. This line is the through line and here one dotted lines. Now, in this case, this filter separator with manual drain, there is this is basically a separator and manual drain is there. Okay. And this is automatic drain. If we put this one automatic drain, and if we use this this is filter separator with automatic drain. Okay. And this one oil lubricator with manual drain, and this one oil lubricator less drain, there is no drain is there. I think this one of that should be drain line, means dotted line should be there, I think. So, and this is oil lubricator with automatic filling. This is a cooler. When you see this arrow is going outside, it will be cooler. When you this is also cooler, but this is basically it is also shown that some liquid is flowing through. Why liquid? Because this arrow are completely darkened. Now, when this arrow is going inside, then heater. Just look at the difference between the heater and cooler. This is also heater. Inside arrows indicates introduction of heat. Yeah, it might be like this or it might be like this, we can put in any directions. These are basically heater. Now, if we look into this, what we have already studied in IOC symbols and glossary, you can see this is a cooler because the arrow is outside, the heat is going out. So, you can compare with this. Only thing, in this case this is filled and this is not filled, that means this is air cooled or something like this. In this case, as we find this, we can again compare with this one, but we get some additional two lines here, and then this must be either cooler or heater, and then we can see these are the two components what it looks like. This is the main system oil in and out, and this is the cooling agent in or out. Now, a reservoir may be a simple tank. Do not confuse with this the accumulator, because accumulator will have no line in the other directions, and this is a small reservoir, and these are reservoir. So, if it is shown that it is open, then it is usually vented. No reservoir will be without any cover. There will be cover, has to be, because when the oil is exposed to the air, so more oxidations and more deterioration will be of oil will occur. So, to prevent that, it should be closed, but usually it will be vented. That means, inside if there is a gas, that gas will automatically come out when certain pressure will increase. But in some cases we need to this reservoir is pressurized and closed, and their venting is only maybe it is again regulated by some pilot system. Some system signal is there which will vent. Normal venting is not there. So, for that pressurized we can show that the reservoir is like this. Now, this reservoir is baffle. What is baffle? Usually you will find inside the separator is there. So, first oil is coming over here and then it is going this side. So, many contaminants will remain at this side and suction is usually in the opposite side. So, return in one side and suction in other sides, and again such baffles are like that. So, this is connected at the bottom, then you will find another baffle is and top portion is clear, oil can flow like this. The next baffle you will find it is connected with the top and oil can flow like this. So, these baffles are used with a one is connected with the top and one is the bottom, so that return oil when it is coming over there, first of all the heavy particles that will be remain here, then oil will flow and then it will flow like this, then again flow like this. By that process, first of all the better heat exchange will be there. Secondly, the adhesion will be removed, that mixing of the air that will be removed. It will also act somewhat anti foaming, and in other sides you are getting relatively stable fluid for again for the suction. Okay. So, when you would like to mention that a reservoir with baffle is required, you can present like this. Now, this is reservoir with connecting lines. The connecting lines are there above fluid level. Sometimes the connections are above fluid level, and if you show this below fluid level, not lever, this should be level. Now, these connections you can show, then you can mention here that one is for suction, another is for return, such things. But you should remember in both cases, both the suction and suction has to be within the oil obviously, but return line also to be within the oil, otherwise there will be too much foaming. But this is a special case where you are keeping some lines above the oil, some pressure purpose. Okay. In that case you have to indicate like this. This is air breathing. This in that case if you present this one, the air breathing is necessary. Now, this you see, do not confuse with this a pump other thing. This is a pressure gauge with an arrow inside in a circle. This is a pressure gauge. Again, if you draw a straight line and with these symbols means it is a flow control, but once you present like this, these two lines in a circle and this inside it, this is flow meter. Okay. Now, accumulator will look like this. Look at this reservoir and accumulator. If we add one line there, that will be reservoir. If you do not add a line there and if you simply put like a balloon, then this will be accumulator. This is also an accumulator, but it is a gas charge. This side a gas is there. Now, if this accumulator is spring loaded, then in that case this line and there will be a spring. Accumulator means that here this will be gas or air and here the liquid. Okay. So, while we are trying to present an accumulator, either you can put simply and you can specify this, or if you are specific about this to show that this is a gas charge, you can use this one. If it is a spring loaded, you can use this one. Okay. Now, as well we have to present the prime mover. Normally, you will find in most of the cases this electric motor, then you can just put like that EM, or if you use that engine, then you put M. Engine we call engine, but usually it is also called motor, electric motor, and IC engine is also a motor. So, you can specify like this, and you can see this not much difference, but it is a power line. Usually you will find with a pump, sometimes this symbol is given, power source, oil or air or oil. No, this is a power source with air or oil. So, this will be filled in case of oil or not filled in case of air, and whereas power line, this is a line is like this, but very difficult to distinguish with these main hydraulic lines. A coupling is shown like this. Okay. Then the crossing power lines we have learned earlier, we can use this one. This is non-connecting. If you would like to show at the junction point connect, what you have to do, move one of that slightly right side or left side and show the connection. That means this is junction point, otherwise this is a crossing line, but best way is that you can cross like this or you can cross like this. Okay. Now, this is a drive shaft, not so much meaningful, but this is a drive shaft, and rotating coupling is designated by this one, and this is a on off simplified switch. That means, this on off switch usually not pilot operated, it is normally manual operated, and this is just to stop the line. You will find that either it is a just single lever, a ball joint is inside, a ball is inside, ball with a hole, that if you make the line connected to the hole, then it is being operated, or you just simply rotate in the 90-degree directions, it is off. So, this is sometimes used in the hydraulic lines. Now, another important aspect, in many cases the color codes are used. Red means operating at system pressure, blue means return line or exhaust flow, green means intake or drain flow, yellow means measure, usually meter flow or control line flow, and then if you use orange, then it is reduced pilot pressure, and violet means intensified pressure, very high pressure, and if there is a blank, that usually inactive lines. That means, this is filled with water, filled with liquid, but no pressure is there. This is mainly used for hydraulic lines. Now, we have to make this orange, and difference between orange and red. Usually, you will find in a same drawing this you can understand the difference, but where only say suppose red line is there, do not confuse with the orange. looking into a little study into the components will give you the idea whether it is pressure line or the ordinary line. Now, then the lever, cam, etc., these are designated by, as you have seen, say this with these double lines with a component, say this is the main component. With that, if this symbol is added, what it is, this is a practically rectangular box with one line is going outside, that is a hand lever. Say in earlier when we are learning the ISO symbols and glossary, I was telling that this extended line means hand lever. So, this is an indication of hand lever. Then this is a, if it is slightly inclined and one line is left side, in this is a foot pedal, and when this rectangular is just rounded, the end is rounded, then it is a cam follower. Now, if it is a button sort of things, then it is a roller operator. Okay. Now, if it is with a symbol like this, then it is a lever. This a lever is fitted over there. Now, this hand operated means in many cases you will find that lever, say a manual valve, there a lever is given. The lever means that usually one point it is fixed and some intermediate point or maybe the extreme point is there to move the other component. The one is fulcrum point, another is to move the component. So, that is lever, and hand lever may be that one also. So, hand lever may includes this type of lever also. But hand lever means it is for operation, a lever is there. It might be a simply shifting or with a fulcrum like that. Okay. Such details you have to mention perhaps by writing or showing the detail design. Now, this is again this maybe this general symbol is that manual, it is like that. So, I think this line will be completed up to this point, but only important is there the other side is extended, this line is extended, and say this is a cam or toggle, it is meant by this one. This is again pedal, this is foot pedal, this is any sort of pedal or treadle. So, this is indicated by this one, and this is push button. This and this has a difference. If you say this is actually cam roller operator, and but this one is a push button, say a reverse D you can say. Now, hydraulic valves, particularly direction control valves, in that case earlier in second lecture we have learned, first of all we can have 3 icons like this. In that icons, intermediate one is having 0, that means this is the neutral positions. A is one operating condition, B is another operating condition. Usually any valve, either it will be on off type, that means either A or B, no intermediate positions, but in most of the cases hydraulic systems and directional control valve, where we need to stop the systems for a while or we need to keep the idle system for a while, then there must have a neutral positions. So, first we can have, while we are designing a valve, then the middle one is the neutral, then A and B, and then there are few icons. From there we can select, say in neutral conditions it might be like this, all are not connected, should bring this one and put here. So, we are trying to construct a symbol for DC valves. Suppose it is complete fully open, then we can put it here, this one we can put here. We can have also that only supply line is closed, other 3 are connected. That means, the 2 ends of the actuator and the reservoir is connected. So, we can take this symbol here. And most popular you will find, say suppose this is a closed center, keep this one at the center, this is A and this is B, or open center, keep this one at the center, this at one end, this is this one at other end. So, this will give 4 by 3 closed center, 4 by 3 open center, 4 ports, 3 positions. Now, you can put this one also at the middle. Sometimes this is put at the middle. Suppose you can choose this one, this is at one end and then this is at the other end, or this is this one at this end and this one at the other end. This is for one specific requirements, but most common we will find either with the closed center or with the open center, then cross connection, straight connection. So, in that way, with these 2 groups of icons we can build several valves. Now, say for example, this first one what we have seen, the T indicates is going back to tank, P indicates this is for pressure line, usually a connected, the P means not pump, usually pressure line, it is called pressure lines. A and B 2 ends of the actuator, this capital A and this capital B. You can mention A B or may not mention, you can simply make this valve. This is called 4 by 3 tandem valve. So, what is tandem? That this connection is there, that means when it is in the ideal conditions, the oil will go to the tank without any resistance. In this case what happens? This usually with these pressure lines there is a relief valve. So, relief valve is set at a maximum system pressure. So, what will happen in this neutral condition, the oil pressure will be up to the maximum system pressure and then it will go through the tank through the relief valve. So, it is a huge power loss, but the advantage is that oil is always ready for work, and such systems will be closed center is usually required for when the very quick stop and on and off we are operating some system like that, then this system is preferred. Okay. So, depending on that requirements also we have to select a proper valve. Now, this is you see the 6 by 3 DC valves. What does it mean? In that case, say this is neutral position, that means there is this oil is actually these two are connected together. The oil is going from this side to this side and it is doing some main system work. What you can do, you can give this line, that system main system is off and you can divert this for these operations to a only particular size, and also you can use this one, that when the main system is off. Say for example, this valve you can use for a forklift truck. In the forklift truck, main line is going for the hydrostatic transmission system which is moving the car. Okay. Now, you want to lift something, once you move the lever, first of all the car will be stopped, then it will start operating lifting, and while again you are lowering, that movement will be off, and then this is for an example. So, it can be made like this. However, in forklift trucks many times it requires that slight movement of the vehicle when it is being lifted or lowering. Say you would like to take something from the rack. So, you have to take it and move out while you are lifting or lowering, you have to take out. In that case definitely this valve will not be suitable, but I have given an example where the 6 by 3 valves is used. Now, this is 2 by 2 valve, so simply it is a on off valve. Now, this is also 2 position, but as you see these 3 ports are there. That means, if we consider the main port, then main port, this pressure port, in that case when this pressure port is stopped, this oil from the actuator going back to the tank, and when you are connecting to this actuator, then your drain connection is off. Okay. So, you may need such valve for some operations. Now, here of course, I have shown this valve, but none of this can compare with this one. Only thing, say this is basically 4/2 positions valve, spring retar and detent solenoid operated. Forget about the detent part. This is 4/2. This is one position, this is other positions, but what we can do by detening, we can make the all ports are connected. So, in a detent positions we can make this one, otherwise normally either this or these positions. Now, if we would like to compare with this valve, suppose with these connections, let us consider this connection is here and these two. What is the difference? In that case, if you leave the valve, then automatically this will come back to this position. Suppose we are using full open center, but in this case it will be full open center only if you use the detent positions. That means, you have to regulate this actuator in such a way that it will be at the detent positions. So, it is operating conditions, no neutral positions, either this position or this position, only in detent positions it will be there. So, for that what is there? This you find that this is not a full line, whereas in this case this will be a full line. Okay. The difference between this and this is there, and apart from that, these we are using only the showing the valve operation. We have not using these symbols, that is whether it is spring return or the armature driven, that we are not showing. That of course, always to be added to show the full form of the valve. And this is the other one which I have also discussed. This is closed crossover. Oh, this is this one actually. This is having also detent. Now, 3/2 DC valve of different configurations. The other configuration and this configuration is different. You have to, depending on the applications, you have to select this. This is also a 3/2 valve. Okay. Now, 4/2 valve have this two. This is basically not off, either this condition or this. Say if we connect to a rotary actuator, then in that case either it will rotate in clockwise direction or anti-clockwise directions. Maybe it is like that, this valve is directly fitted to the actuator, we are operating this way or that way. If we would like to off the machines, then whole main line is disconnected by some other valve. Okay. So, this is, as you see, this 5/2 4/2 5 ported DC valve. As you see, we have 5 ports. How? 1, 2, 3, 4, 5. The 5 ports, but basically this is 4/2 valve, because we have 2 positions and we use 4 ports. So, sometimes it is called 4/2 5 ported valve. Now, in that case the pressure line is blocked, in this case the drain is blocked, the other cross connections are there from some applications. Now, you see this another interesting thing is that these valves, as you see this, we have not used any arrow here, not to show any directions, but say suppose if we take this block, that means basically 3 icon together, and then if we put an arrow, then this will indicate that at neutral position pressure is connected and pressure is closed, pressure line is closed and other 3 ports are interconnected. That means, reservoir and 2 sides of the actuator are interconnected, and this is for cross connection and this is for straight connections. Okay. So, that is simple valve. Now, what we find along with that, these 2 lines are there. This indicates this is infinite positions valve. Now, this is usually for copying machines and other things. It is, you can say, this is a some sort of servo valve. So, infinite positions means this is some sort of servo working valve. Now, here again 4/3 5 ported cylinder ports open to pressure in center positions DC valves, as you can see this one 5/2. So, depending on the purpose, this valve is also used. Now, symbols for hydraulic valves, again some examples and not exclusive, we have exhaustive, not this one. This is again some repetition of that, only thing that you can use this spring, say these symbols are repetition, but once it is shown that if you add this one, this is called spring center. If you add spring one side, it is called usually spring return. Okay. If you show this one, this is the hand lever. If you show this dotted line with filled arrow, hydraulic pilot, and if you show this symbol, this is solenoid operated, and you can use this spring like this or maybe with a cap like this, and this is obviously spring centered and solenoid operated both side, and here spring return solenoid operated one side. So, with this addition with more detailed symbols, what we can add? We can add, this is basically 4/2 DC valve, and we have used one spring. Here what we have used a triangle plus a triangle filled with completely filled, and this is in a box and then a dotted line. That means, this is pilot operated and maybe hydraulic driven also together. It is hydraulic pilot operated spring return valve. That means, this is hydraulic operated, hydraulic pilot as well as spring return. In that case, both the side hydraulic driven and hydraulic pilot operated. Here this is solenoid pilot operated, and there is also hydraulic actuation is there, but this is spring return. In that case, as you find in both the sides, we have added this one. So, by adding such symbols with these main valve symbols, we can also indicate how it is being operated, whether it is spring centered or not, so many things. And as you can see, this is the 4/2 single acting DC valve. In this case, hydraulic pilot and pneumatic operation might be there. In that case, solenoid is there and as well as hydraulic pilot is there. Now, in case of servo valve, as you see, in case of servo valve, you will find that these with this arrow a flow control is also shown, because the it is variable orifice. In case of with respect to the directional valve, direction control valve, the servo flow control valve will have the variable orifice, that is meant by these adding these. Okay. Now, also we are adding this one, that means, this is also pilot operated and this is also variable, as well as this is there is a solenoid. Okay. Apart from that, we have to put two other lines. So, once we put these two lines along with such things, this means that it is completely two stage electrohydraulic servo valve. Why two stage? There will be pilot stage, there will be main stage, and it is a servo valve. Okay. So, for that we can use this symbol. Now, say we are coming to the pressure control valve. In case of pressure control valve, the simplest one is that poppet function. First of all, we will show these poppet functions. You will find that in many cases a valve is drawn like this. That means, it is normally closed. In some cases, you will find this is there and it is shown like this. That means, this is open, normally open. Now, the direct acting pressure relief valve are shown like this. So, this will be there normally closed, and along with that there will be a symbol like this, and this is the you can adjust the capacity. And in this case, if it is a pilot operated, in that case you will find a straight lines which can come here and here. Here means it is open, and here means at the top, not on that line, is closed. Now, this is again pilot operated pressure relief valve, but this one is having one is that this is a closed one, this is also another closed one, but this is operated by the pilot as well as it is a flow control. This is a special feature, but you can show this with this together. This is a complicated one, but better maintains better pressure relief conditions. Okay. Now, this one is that pilot operated relief valve, external pilot, internal drain, this is pressure reducing valve, this is pressure fixed and variable adjustment. This one indicates pilot operated relief valve, pressure reducing valve, fixed and variable displacement. That means, once you use these two signs, pressure reducing valve is also a pressure control valve, pressure relief valve is also a pressure control valve. In case of pressure relief valve, oil is flowing from this side to this side. You will find that the pilot line is from the upstream. Okay. But there is no pilot from the downstream. If there is a pilot from the downstream also, then this is a pressure reducing function. In all pressure reducing functions, you will find that it is acting as a pressure reducing valve as well as pressure relief valve. So, a pressure reducing valve with pressure relief valve totally meant by this one. Usually, you will find wherever you are using a pressure reducing valve, there is also a separate relief valve which is connected near the pump. So, forget about that part, but then again where the pressure reducing valve is there, this will be a relief valve inbuilt there, because some flow has to go through this pressure relief valve there. Now, this is what is the difference between this and that. In that case, pilot operated relief valve, external pilot, external drain. You see, there is no line from the downstream. So, this is a relief valve, but it looks alike, only thing this line is not there. External pilot is there as well as external drain is there. And this one pilot operated pressure reducing valve, in that case the relief valve function is not shown. So, this is a pressure reducing. Whenever this pilot connection is from the downstream, it is a pressure reducing valve. And it is very difficult to remember all such symbols. We do not expect that you will remember all such symbols, but it is just to have an idea. Now, this is, as you can see, this pressure reducing valve with a check valve here. This is remote pressure adjustment, direct operated, and counterbalance valve looks like this one, sequence valve looks like these ones, and unloading valve. So, while you are trying to study such valve, you should study the circuit along with this, and you should spend more time to study such valve. This is for your instruction, I am just going through that, but you should spend more time to learn how these symbols are justified with their function. Now, as you find that pressure reducing valve 3 positions, this is pressure switch. As you can see, this is 1, 2, 3 positions, it is either connected with 2 or connected with 1 and 3. So, this is a pressure switch. Depending on the pressure, this will be connected this way or other way. The sequence valve external drain, sequence valve external drain load varies with back pressure in the tank line. So, there are many things to understand and then to remember such symbols. However, if you go for circuit design, this will be available in your hand, you can simply put there, but you have to know where to use which one. Now, this is a flow control valve, it is a two-way pressure compensated flow control valve. So, this line, this arrow is there, means this is the directions of the flow, and this is the three-way pressure compensated flow control valve. If the box is there, perhaps this is a pressure compensated, and if it is used without this box, perhaps it is not pressure compensated. This is a throttle valve. Throttle valve and the flow control valve is almost the same function, but in case of throttle valve, you may not find it is simply a flow restrictor. So, that is called throttle valve, whereas flow control valve, there is some device, the control is there and the excess flow will go to the tank from that valve. In that case, the throttle valve, that excess flow has to go through this pressure relief valve, which is set again a system pressure. That means, in between this throttle valve to pump, the pressure will be always to the system pressure. It is something like that. So, you have to study in details while you are designing such circuits. The check valve with spring, check valve without spring, which I have shown earlier also. In that case, now we come to the pump. In this pump, what we find, a circle and a triangle inside is completely filled in. This is a constant flow fixed displacement pump, single outlet, unidirectional input shaft rotations, and with this one we have not shown shaft, it is not necessary always. Now, in this case it is double outlet, that means bidirectional input shaft rotation. This is usually either bidirectional shaft rotation is also possible, or bidirectional flow is possible simply by changing the swash plate angle. This is complicated, but you can, once you find these symbols, you can think of this designation. Now, with this, if you use an arrow, then with this feature, this will be variable displacement. In that case, in this case, it is a fixed displacement. Here it is the bidirectional with variable displacement, and you can see this is the ISO symbol is like that for a pump. You can compare this with this one. Now, the motor is just reverse, the arrow are put in the opposite directions and other designations remain same. This is motor, arrow going out means pump, arrow going inside means motor, hydraulic motor. Now, very often we use this term HST, that hydrostatic transmission. Now, total hydrostatic transmissions, this term meant there is a pump and there is a motor. Now, if it is connected like this, this is a closed circuit. All systems are, say, there is a pump and actuator with a directional valve, that is also a hydrostatic transmission, but that is open circuit. Now, this is a closed circuit with a variable pump and fixed displacement motor. Now, if in many cases you will find that instead of piping connections are there, this has simply one input and another output, and you will find that this is a pump side you have connected to a prime mover. It is rotating at a constant pitch, where by manipulating something in between, you may find variable output also. So, that is basically inside there is a pump and motor. So, this construction is also possible. Now, some sophisticated and hybrid units are like that both pump and motor, you can use this as a pump as well as motor, but this is only unidirectional, whereas this is hydraulic pump or motor single flow. That means, this is either you can use for pump and motor if you just reverse the flow directions here. In that case, you can use perhaps for both directions to have this pump and motor features. There is some difference between this and that. This is detailed, you have to study in details with the component and machine. Now, in this case, this is dual rotation. No, perhaps this one I will tell you, this one perhaps that if you rotate in one direction, it will act as a pump. If you rotate in the opposite directions, that means with the same flow directions, if you use the flow and try to have the output, then it will act as a motor. In that case, you rotate in one way and you can have this as a pump, and also this can be used as a motor by changing the valve configuration or something like that. But this is, you can say this is added together. If you this both side is pump and motor, so this will work for dual rotation. And also we can have such configuration with variable displacement. Then there are some mode, that is some simplified symbols are there. These are usually used, say for example, this already we have learned. In that case, this is a bidirectional variable displacement pressure compensated. So, pressure compensated means there will be a arrow like this. In that case, there is an external drain and this is a pump unidirectional variable displacement, and this is of course non compensated. In this case, this is compensated, arrow is there, and this is bidirectional. Okay. Now, these are the actuators. In these actuators, there is no spring return. Here is some spring is there. In that case, double acting cylinders, thin piston rod, not usually under compressions. So, this one we do not use for under compressions, but this we can use for used in under compression. Now, if we add something like this, then there is a cushion effect. This cushion effect means physical cushion may not be there. It is like that when it is reaching towards the end of the pistons, then there will be a flow restrictor through which the flow will be in such a way very slowly that piston will touch the cylinder. So, there will be some cushioning effect. Now, this is cylinder with adjustable cushions. This cushion can be adjusted, that means you can allow to collapse faster or later. Now, this is again double acting cylinder with adjustable cushions. You can see that if it is a single acting cylinder with adjustable cushions only, no mention whether it is a single acting or double acting. Usually it is a single acting because no compressive force is applied here for thin rod. In that case, this is double acting, you will find both the lines are here and this is a thick cylinder, because this can give compressive load as well as tensile load. Now, in this case double rod cylinder. Now, this cylinder again may be very thick or thin. Okay. Now, this is a telescopic cylinder. In that case, it is like that if you allow the oil to go inside, then first this one will move, because this is having a larger area. So, with a small pressure it will work. Then when this will be fully extended, pressure will gradually increase, and with this, because this is handling the same load. So, with the smaller cylinder it will move. So, this is a we will get telescopic action. Where it is used, where we are we need very long extension, in that case we use the telescopic one, and this is intensifier. What we find that if we allow the flow this side with a low pressure, we can have much higher pressure this side. Okay. And this is, we have followed one book. This book is available in our library, and this is of course the from the net. You can download this and you can learn about the ISO symbols. So, thank you for listening.